first thing we're going to look at today is an introduction to a two-sample t-test. Please turn to slide 2 to examine the main points for an introduction for this test. The purpose of a two-sample t-test is to determine if the variable of interest is different between two samples. It is important to note that with this test, a variable must be quantitative. A basic example of a quantitative variable would be a measurement of something. Other variables, such as color, don't meet this criteria. This test involves scrutiny of several assumptions before testing can begin. According to the two-sample t-test help document, these include independence, normal distribution, and equal variance. As the name suggests, these assumptions help us decide whether or not the test will produce results that will be accurate or useful. This is very similar to checking to make sure an everyday appliance like a vacuum cleaner is plugged in before attempting to use it. If you don't look and see what's going on with that power cord, you're going into that situation somewhat blindly. It's the same basic concept here. This test is used in conjunction with what is called a Levene's test. A Levene's test is used here to satisfy the equal variance assumption that we mentioned before. According to the two-sample t-test help document, if no information is given about the variances, then one must check the variance for equality first with the Levene's test. So now that we have a basic idea of what a two-sample t-test does and what is required before you can actually do the test, let's look at an example of what a question might look like that this process could help a person with. On slide 3, you can see an example question along with some accompanying data that I arbitrarily typed up. I used the same basic style for asking questions in this case that the textbook Business Statistics 3rd edition uses on many occasions, so the credit definitely goes to them for the style of the writing of the question. But I used numbers that I made up rather than numbers from their problems so that I could be sure that I was inputting my own numbers into JUMP and hopefully producing a unique result to present rather than something that could just simply be looked up. The question reads, an office manager has a team of salesmen and he is looking to optimize the method for processing successfully completed sales. He has two options, method A and method B. He thinks that method B will be faster. To find out, he has a sales team use each method for 10 sales and record their times. Is method B faster? This example shows how everyday questions that we run into can be solved given there is available data to go along with it. This particular example applies to business, but really it can apply to any question that somebody might have as long as it takes on that similar format. For example, a person could be interested in which of two routes to work in the morning would be fastest for them to take. But it wouldn't work for someone trying to figure out or asking the question, for example, like who is the fastest runner? It's just not quite the same thing. So now that we know what to look for in setting up the problem, let's move forward by working out the example problem. Basic steps associated with this type of test will be followed here using the same process shown in the two-sample t-test help document. Checking of assumptions is the first step in the textbook. Business Statistics 3rd edition tells us that when appropriate assumptions and conditions are met, we test the hypothesis. Slide 4 shows the JMP outputs that I put together. If we look at the dot plot, we see that the nearly normal condition is met. And if we look at the JMP output for the data, which is just below that, we can see that the variances can basically be assumed to be equal. Next, we will continue the process by moving on to slide 5. We must select the correct statistical test for this question. We're going to be needing the two-sample t-test to give us some meaningful results. Our significance level is going to be 0.05, which is pretty standard, and this is the number against which we will be comparing the p-value. Writing a hypothesis is the next step. The question states that the manager believes that method B is going to be the best option. So in order to accomplish this, we're going to set our HA, our alternative hypothesis, to show that the mean for method B is going to be less than the mean for method A. And you can see that demonstrated on the slide to the left of the jump output. Conducting this test is the 5th step, and using JMP I have successfully ran the two-sample t-test, and the results of which are directly to the right of the hypothesis on slide 5. We can see that the p-value is shown to be 0.9600. Making a decision on the hypothesis is the 6th step. This p-value is going to be what we use to make a decision on whether or not what the manager is thinking about these two processes is correct. In this case, the p-value is large enough that we actually can't reject the alternative hypothesis shown on slide 5. Summarizing the results of the test using wording that other people can understand is the 7th step. But what does this all mean? Well, to put it into terms that other people can relate with, we did not uncover evidence based on this test to show that method B is going to be the more attractive option for this manager. Keeping it simple and generic like that is going to make it easier for people to understand the end result. So now that we have done our test and gotten our result, we can begin to look at what this means for the manager in the problem. Our 6th slide is going to be looking at accepting or rejecting the null hypothesis. Recalling the information from slide 5, we know that we did not reject the null hypothesis in this case. The question I usually wonder after that is, well, how do we know how accurate this is? How do we know we can trust these results? Well, since we went through and verified that the assumptions were met, going back to our previous analogy, we checked to make sure the power cord is plugged in. We can be pretty confident here that no issues surrounding those items that we checked are going to be a problem here. But one possible problem is lurking variables, about which the textbook Business Statistics 3rd edition says there's always the possibility that some third variable, a lurking variable, is affecting both of the variables that you have observed. As the text says, these lurking variables can give us false impressions of things, and they aren't always easy to detect, in my opinion. Making recommendations based on findings is the last thing that we will do with our example here, and we'll also be moving to slide 7. Our original question asked if method B was in fact better than method A, as the manager suspected. Well, we didn't find any evidence of that in this case. That doesn't mean, however, that if the manager did this test again, he would be guaranteed to see the same results, because the numbers might be different. This is simply an analysis of what we happen to observe this particular time within this particular hypothetical question. In conclusion, I'd like to review the material associated with a two-sample t-test on slide 7. First, a review of our process. Hypothesis tests here. We use a 7-step hypothesis test here, which consisted of checking the assumptions and forming the hypothesis, selecting the correct test and the correct significance level, conducting the test, making a decision, and summarizing the results in a way that other people can understand. The overall goal here is to be able to start make sense of what these numbers have to tell us. And in closing, statistics can help us solve many of the problems, such as the example we used throughout the presentation.